Sorry, what did you say, Steve?
I think that's Fallout 4.
Oh,
Possibly.
On the computer screen.
Very possibly.
Recording.
All right. Welcome to T-14. Going to talk about custom configurations. As more often than not, when you're dealing with different types of uses, either the configuration you get when you buy the computer off the shelf is going to be overkill or not even remotely enough to handle what you need it to handle. So you may not want to spend full price on an off-the-shelf computer when you can basically work yourself into a stripped-down version and it be more precise to the needs that you have. And if you need something significantly more robust, you don't want to rely strictly on the components that you were given because it won't suit your needs. During this particular T session, you'll be able to describe a few basic different custom configurations to meet common client needs. You'll be able to describe the features and characteristics for those different custom configurations and workstations. And given a particular scenario, you will be able to select the appropriate components for a custom PC configuration to meet the specified customer needs. This particular thing is a big part of A+. They love asking scenario questions with regards to this, and then they will ask which particular items do you need to customize on this to be able to fit the needs that the customer has at the most economical price. Because, you know, if we're able to, let's upgrade everything. If you're not able to and you only can do certain components, you need to focus on the bare needs first. Communication and growth mindset. Obviously, you are going to want to have a very good conversation with your operations team and operations supervisors to understand exactly what their needs are as their needs change, so you know how to modify, upgrade, and change the equipment to best suit their needs while maintaining the most economical price. And keeping aware as these needs are changing, using a growth mindset to better understand the technologies that can better aid your operations teams in their efforts for the business. Specializing custom PCs. You know, some computers, again, sometimes you may only need like a stripped down version, like a point of sale device like you would see at, you know, Walmart, Target, or what have you. Underneath those registers, they'll have basically a stripped down PC in there that has a very, very specific purpose. They don't necessarily need all the bells and whistles that you would have on a normal desktop. It doesn't need sound, it doesn't need huge amounts of RAM or any of that stuff. It's performing a very specific function, and it does that function well. And so it only needs a few components to do that. Now, somebody who's into 3D graphics design, they're going to need a very robust computer with a lot of computing power to be able to render the images that they're trying to create and the environments that they're trying to create. So we have to be able to modify these computers to fit the needs as people require. Three most common types are the workstation PC, media workstations, and specialized consumer PCs. Those are three generalized types. So first one up to bat is the thick client. And essentially all a thick client is, that's an off-the-shelf computer. That's basically how you would get it from the store. It is what it is. It serves its functions, and it's pretty much what any consumer would get if they went to Best Buy or Walmart or what have you and just bought a computer off the shelf. That is considered a thick client. There's no upgrades needed. It is generally pretty baseline across the board. Nothing's taken away, nothing's added. any questions with regards to a thick client? All right. Next, we have a thin client. This particular computer is typically designed to outsource much of its workload. They have just enough hardware in them to power and run the selected base operating system. Some of them don't even have the operating system really on site. You know, they're really going out to a server and operating off of that server, typically called a Pixie server. But it will have a base level operating system on the actual device itself. Can anybody think of a really popular one that is being used right now in the mobile device category that a lot of people tend to use, would fall into this category?
Chromebook?
I didn't hear you. What?
Is it Chromebook?
You are dead on the money. Absolutely, a Chromebook. Point of sale machines would also fall under this category. And more and more you're seeing them in offices. Rather than putting a tower at every workstation, they're putting basically a mini thin client there and having people work off of virtual desktops and operate off of a hypervisor or something along those lines, rather than having all that stuff stored on the individual computer. It also increases security when you have something along that lines, because if that little mini tower is stolen, the data isn't there on the actual tower. All right. Basically, the only real main requirement for a thin client, because it is kind of a stripped down version, is it needs to have solid network connectivity, because it has to be able to connect to those servers and talk to those servers to be able to get all the resources it needs to be able to accomplish its tasks. It's not operating off of its own resources, it's utilizing something connected through the network.
I have a question, Mr.
Go
K.
ahead.
I saw that some organizations have only just monitor and a keyboard and a mouse. So they don't have a kind of these machines. So what we call that? Is that still, that is thin client?
Speaking of all-in-one, maybe?
Yeah,
Just
that's the
monitor.
only thing I can think of is like the all-in-one machines that like Microsoft has and Mac has as well.
And that would be more of a thick client just without the box, because they're going to run full-fledged everything as opposed to, right?
I am fairly certain nowadays you could order a thin client version of an all-in-one though.
Okay.
So it's still a computer, it's just all within the monitor, and it's still reaching out to these servers, connecting to them. And I mean, you can do that with a thick client too. It's just they're stripping down the resources in an effort to save money, essentially. But the main component, as we were saying, for the thin client, that is an absolute matter requirement, is a solid network connection so that it can talk to the servers to obtain the resources it needs. All right. Typically paired up with thin clients, you have virtualization workstations. Enables to run more than one operating system at a time on a particular computer. Virtualizing PC is also called a VM. And so the actual PC is called the host. The virtual machines that you create are called guests. And all resources for the PC are shared between these particular virtual machines. That's why we were talking about you needing to have multiple cores so that your computer can operate individual operating systems off of each core. And if it has multi-threading for each core, you could operate two. Saves on hardware costs, allow you to test out new things to make sure that they would actually function properly. Would grant you access to multiple operating systems on your particular device. And you can have dozens of VMs on your computer at any given time. You just wouldn't be able to have necessarily all of them up and running at the same time. So it's when they're up and running, that's when they're chewing up the resources for the computer. When they are not running, they wouldn't necessarily have those resources dedicated to them. And these virtualization workstations are great for testing software out, and also testing for viruses and stuff like that, testing out updates to see how it's going to impact whatever software you have running, to see if it's going to negatively affect it, have no effect at all, and allow you to verify this stuff before you roll it out to the rest of the organization. All right. The big thing for virtualization machines, as we just talked about, is a multi-core processor. You would need at least one for each individual operating system you are running, and a lot of RAM, because that's where you start getting into trouble with when you're doing virtual machines, is sharing your RAM memory. Because while that machine is on, it will have a dedicated amount of memory, like minimum requirements for Windows 10 for RAM. Emery, can you tell me what it is? Or anybody, can you tell me what is the minimum RAM requirements for Windows 10 or any 64-bit Windows operating system?
8 gigs.
4 gigabytes.
Isn't it 2?
You said 8, right? Or
I believe it is 2.
I think it is 8. 8
It's 2?
gigabyte.
I thought it was 8.
We're talking about bare minimum. Yeah, it's 2 gigs. For any 64-bit operating system, the absolute minimum RAM requirement is 2 gigs of RAM. So, and that's bare minimum. It's not necessarily optimal or recommended. That is bare minimum. So if you have 6 VMs operating off of your computer plus your host, so you have 7, you would need 14 gigs of available RAM at that given time to be shared amongst all those machines. Just kind of give you an idea. So whenever those virtual machines are active, all that memory is allocated. So the main upgrades for a virtual machine: upgraded CPU, multi-core processor, and then as much RAM as you can get. Those are the 2 main things you would look to upgrade for VMs. And again, we're speaking in pretty general terms. All right. Moving on, graphics workstation. If you're in any kind of engineering and operating off of CAD programs, doing 3D rendering, 3D design, graphics design, anything that's going to be very, very heavy, intense on graphics is going to require a lot of computing power. So obviously, what's the first thing you think you're going to want to upgrade?
RAM. And a good card.
Video card? You think RAM?
Yep.
Yeah.
Anything else?
Better processing.
Better processing? Possibly. Let's see. So the things that they would recommend for you to upgrade would be a solid state hard drive. Why would they recommend a solid state hard drive rather than a regular mechanical hard drive?
The data can be accessed fast.
Absolutely correct. It's able to access that memory much faster. So you would want to upgrade to a solid state hard drive, maximizing RAM. Jerome was on, or Jermaine was on point with that one, excuse me. So maximum RAM, as much as you can get, computational power. High-end video cards and with its own memory, processor, and display adapters on site, as well as upgrading your monitors, high-quality monitors. Audio editing workstations, sound mixers, things like that. High quality audio, what kind of upgrades do you think you would need?
Video card, not video card, audio card, higher hard drive, and possibly memory also.
Okay. If you're running multi-channel audio, it can be almost as intensive as graphics. So you're definitely going to want to upgrade the audio card in there. You're going to want multiple input outputs for microphones and speakers and other instruments, and to be able to manipulate that information as it comes in. The other end of that, video editing. When we get to video editing, also very, very processor heavy. So you're going to want a powerful CPU with as much RAM as you can possibly, get in there. Since it is a very computationally intensive process for editing video. The other thing that they recommend is a second monitor, so that while video is rendering essentially on one, you could be still functioning on the other and operating. You would want multiple hard drives, typically set up in a RAID for faster writing and data integrity for storage, and video editing takes up a ton of storage, especially in the rendering process, which is partly why YouTube is a loser as far as profitability, because storing all this video and a lot of it is in high def takes a ton of storage, and they're offering that up a lot of times for free. Although I think they may be moving away from that. Home server PC. This would be a centralized PC in your household that you would kind of use as the house for all the resources. Like everything would need to go through there as far as your media, your file sharing. Like if you want to keep everything in a centralized location, but have it accessible to other computers in the household or that are currently on your network, a home server PC would be the one you would typically want to go for. It would allow for media streaming, file sharing, print sharing. That's typically what we use our main one for. Is the main computer for the house is essentially the multimedia hub for the entire house. Everything essentially connects to that for streaming. And they also may call that a home theater PC. You want CPU and RAM tend to be very important with that. You definitely want to have that multi-core processor to handle multiple requests at any given time, as much RAM as possible to service as many resources as it needs, depending on how many people are going to be trying to access this information at any given time. And since the services are going through the network, you want a gigabit NIC for the house so that you don't have much lag, especially if it has to do with media sharing, such as high def video. And it does recommend 2 or more identical hard drives or mirroring full RAID configuration if you're going to do something along these lines. And this is also not a complicated thing to set up as well. Questions so far? All right. Home theater PC. It's not an overly complicated one. It's basically just there to manage your media files, play music, watch movies, television, and it typically has 5 components as it's stated. You would have it hooked up to a monitor or a TV projector. More often than not, it would be a TV or a large TV or projector. You would have it set up to surround sound speakers, stereo receiver, though I would not necessarily say that was a requirement. You would have the actual base station and then need the network connectivity if you're going to be streaming from outside sources or sharing this information with the rest of the household. So the main upgrades you would want to make were a video card, which would support very large monitors or in high resolution. Fast NIC card, gigabit preferred. And then also upgraded sound to support 5.1 or 7.1 Dolby Surround. And they recommend a DVD drive, but those are pretty well obsolete at this point. It's either Blu-ray or you would typically download the video via the net. Questions with regards to home theater PC configuration? So upgrades, basically upgraded sound, video card, and gigabit NIC. All right. Gaming PC. Now, there's going to be what they state here, and it does differentiate from the exam, and we'll see if we can figure out as to why. For those who are going to get heavy into gaming, obviously a standard PC is definitely not going to cover it. You're going to need to do some upgrades on that PC to function. So they recommend basically kind of upgrading almost everything. Fast multi-core processor, lots of RAM memory, high-end video card, high definition sound, and upgraded cooling capacity. That's one of the big ones for this one. Is the upgraded cooling is specific to this one. Now, for the A+, they will say you don't need to upgrade the RAM. Can anyone tell me why that is? If you're in a pinch, that's one of the upgrades you don't necessarily have to make is the upgraded RAM, and there's a very specific reason for it.
I'm guessing mother. I don't know, honestly.
Because it's temporary storage? I don't know.
The
Uh,
cache.
Well, I mean, video games tend to be very computationally intensive. So there's a lot of, it does use a lot of RAM, of short-term memory. But why would they say specifically that you wouldn't necessarily need to upgrade the RAM? And you have to kind of think a little bit deeper on this one. I'll give you a hint. It has to do with this right here.
Because there's extra RAM being added with the video card.
Yes, the video card has its own RAM, and it's going to be utilizing that for the most part. So you wouldn't necessarily need to upgrade the RAM on your or on your actual PC. And there is debate on the processor because you're relying more on the GPU. But I know the big one is RAM memory. If you have to choose between giving the RAM to if you only have X amount of components in the exam, you have to choose between giving the RAM to the gaming PC or to the other PC. You give it to the other one because the gaming PC doesn't need it because it already has extra RAM built into the high-end video card.
But in real life, we would get extra RAM, right?
I mean, yeah, in real life, you're definitely gonna make those upgrades. And that's one of those points we were talking about. The exam versus real life, and they're viewing this as you have finite amount of resources and we need to make these upgrades. What resources are absolutely the most critical to upgrade? Typically, yeah, if you're building out a gaming PC, you're not going to skimp on the RAM. All right. Here's an example of like what the modern ones look like from obviously 4 years ago. And as we were talking about earlier, where when we looked in at the motherboard and all the other components, they, were all various different colors and stuff like that. Here you can see for aesthetic reasons, they've kind of made all the wires and cables the same color because it looks better. And a lot of your ports and slots will be of similar color as well, rather than using different types of colors. Also attached here to the CPU, they do have a liquid cooling system. As you can see, the two hoses coming out that are going to go up to the radiator, which would equate to the upgraded cooling. So any questions with regards to a gaming PC upgrade? In a very general sense, obviously. Again, it's 4 or 5 years old. Well, Scott, yes, it could be confusing, but it's also something you would want to be aware of when you're working on something like this. That's where the pictures come in handy, and also the various connectors you're using. Knowing the different connectors on the site helps you identify where they need to go. The documentation should tell you where the front panel connectors need to go. You definitely are going to want to consult documentation for this, but a lot of gaming PCs will typically be, they'll have a clear panel on one side because it's not just a PC, it's also a display piece. You're showing off, all these, fun upgrades that you've put into your computer. I mean, they have lighting kits, all kinds of fun stuff that people have done. I've seen they have open air PCs where they essentially are making it like artwork on your wall, where you have multiple pieces connected to your wall and your PC is essentially built into the side of the room versus being in an actual box. There's a lot of really neat things that they've done with them to make them more than just an actual computer, but more of a display piece. So I definitely, if you haven't done it, take a few minutes. When you have a few minutes, take a few minutes and just Google like open air PCs or gaming PCs and just see some of the crazy stuff that people do and put together. It's absolutely amazing, some of the stuff that they do. All right. Here's some examples of gaming PCs from a while ago. Just to kind of give you an idea as to, entry-level prices. And these would be base models that typically would upgrade from here. So yeah, Emmanuel, if you got a picture of yours, take a picture of it, share it. Here's a basic look at video cards that we looked at them a little bit earlier. These would be the upgrades. You have the PCIe connectors here, and then you have the multiple outputs here. They typically have their own cooling system attached. Some of them will allow you to do liquid cooling on the GPUs as well. So, I mean, there's lots of fun upgrades you can do. But typically, so you would know what you're looking at, this is what a GPU would look like. Here is a great screen to take a screenshot of, and it will tell you which things you want to upgrade for each type of computer. So if you take a screenshot of anything from this presentation, this is the one, because this kind of sums it all up in one spot, where you have your thin client, thick client, gaming, VM machine, audio, video editing, and graphics, CAD, CAM machines. And I don't think the presentation went over network attached storage, but the main thing with that is storage and gigabit NICs. So gigabit internet connection to be able to access that storage. If I remember correctly, Emmanuel, you said you were setting up a NAS in your house, right? Oh, you want to in the future? Yeah, that's a good one. And so as you go through, try not to get confused. There is NAS, which is network attached storage, and then there is SAN, which is storage as a network. And that is a much bigger endeavor. I mean, you're talking, that's like a massive server farm with ultra high speed connections between them versus a network attached storage, which essentially is a computer that is dedicated for being a storage device for the house with multiple hard drives. All right, questions so far? Did everybody get a chance to take a screenshot of this, use for future reference? If not, we will be dropping the presentation into Slack for student pay, so you can go back and kind of review it, go over it, just to be sure you have a general idea as to different modifications you can make for different types of computers for different jobs or personal needs. Here we go. Network attached storage. You can set them up instead of doing a server for your house. You could just set up a network attached storage, something like this, which basically can work as a memory hub for the entire house. And typically you want a massive amount of storage on something like this. You want to have an ultra fast internet connection so that multiple people can be accessing this information at any given time. And it could just be a couple hard drives put together like this. It could be a full RAID array, all depending on the time, money, and effort you want to put into it. But it's great for file sharing, especially in small offices as well as home use. So SOHO, so small home or office. So any questions with regards to NAS or network attached storage? All right. Kind of brings us to the end of this one. This one is a particularly short one because it's just understanding this like little tweaks you need to make to each type. So we should be able to describe different custom configurations. I do recommend you kind of review them, get an idea as to when you would want to implement something like that, because there will be scenario questions that they will ask with regards to that. To meet your common client needs, describe the features, characteristics, and the different customizations you would need to make to each type. And given a certain scenario, be able to select the appropriate components that need to be upgraded in order to meet the specifications. And we're talking about bare minimum upgrades, not ideal upgrades, because you're typically going to be operating within a fixed budget with regards to that. So any questions though for thus far? All right. Stop the recording here.